So day 3 of logs and exponents, graphing logs. But before we get to graphing logs, we probably need to remember, the basic log stuff. Do you remember how to rewrite log base a of b equals c as an exponent? Yes, I see at least one person doing this thing, like the loop-de-loop or the fish hook.
Yeah, I remember that.
Do you remember where it starts? How well do you remember it?
Not that.
Not that well. It's like some fish hooky thing going on. You start at the base, A is the base, and loop around.
I was going to say that.
That's what you're thinking?
Yeah. But the other way, I was thinking the other way for no reason. I don't know. I was thinking.
So that's how we can sort of translate logs to exponents. And that's going to be a big chunk of what we do the next week and a half or so. If you get stuck on a log problem, make it an exponent problem, because you probably know exponents better than you know logs. And
Is it C?
A to the C, that's a C. A to the C equals B. So a couple of things about this. B, well, we'll come back to it in a minute. Number one, the argument of a log, that's B, must always be positive. Because you can't guarantee you're going to get a negative number there. And well, the reason is we should probably start. The base is always positive. Let's start there. Okay, you can't do a log with a negative base. So A is always positive. Yeah, that makes more sense. Let's start there. A is always positive by rule, because you just can't do a log without doing that. So if A is positive, and I raise it to any number, even a negative number or a fraction, your answer is still going to be positive. And so that's why the argument of a log, the inside stuff, has to also always be positive. So those two parts of a log will always be positive. Now, your answer, C, could be negative. Because if you did 4 to what equals 1/4, there we go, there's a negative answer for C. What's C equal to? If 4 to something equals 1/4, what would C be? Negative what? Negative 1. So you can have a C that's negative. You can have a negative answer. You just can't have a base or an argument that's negative. Statement 2. Log base 3 of 3 is 1. Log base 4 of 4 is 1. Log base 5 of 5 is 1. If the base matches the argument, meaning you have log base A of A, well, you may not even have to write the loop-de-loop thing or the fish hook. You can just look at it. What this means, what log base A of A means is A to what power equals A? Well, that's got to be 1. And so that's why if the base matches the argument, the answer is 1. But I don't know if that's worth memorizing, because if you know the loop-de-loop thing, log base 7 of 7, that means 7 to what equals 7? Well, it's got to be 1. So I don't know that that one's worth memorizing, because you can figure it out. Number 3, log base 3 of 1, log base 4 of 1, log base 5 of 1. Again, think about the loop-de-loop thing. Log base A of 1 means A to something equals 1. 0. The only way that works is 0. And it doesn't matter what A is. So it doesn't matter what the base is. If you're taking the log of 1, you're going to get 0. That's another one where, do you need to memorize that? I would say no, because you could just figure it out with a really short fishhook thing. Number 4, I think you've seen this before. Log base E is the same thing as natural log. If the base is E, we call it a natural log. This is the most used log we have. Basically, it comes up in calculus, it actually comes up in nature, this number E, and so because it comes up so often, rather than writing log base E all the time, this guy who figured this out, Euler, he's named it after himself, and we just use natural log. And E is from his name, Euler. So you come up with something fun or fancy in math, you get to name it after yourself. There's the definition of E. That's really complicated. That's a calculus thing, so you don't really need to worry about that. Limit, exponents, fractions, infinity, like that's a lot going on there. For us, we talked about this yesterday. E is 2.7, kind of like pi is 3.14. Close enough for most of what we do. If you needed, a more decimals, then you'd have a calculator and you could find the button to tell you what it is. Okay, so the main thing for the first half of the worksheet there is this fishhook deal. Start with the base, loop around to the other side. If you can do that, that's the basis for the next week and a half or so. All right, number 1, some graphs. Now, we just got through saying we don't really like the dealing with logs. We'd rather deal with exponents. And so what I'm going to do is, instead of graph a log, I'm going to graph an exponent. So I start with the base. This equation is a little, like flipped from what we were just looking at, but you still start with the base, loop around. So I'm going to rewrite that as 4 to the y equals x. You okay with that? Because it goes pretty quick after that. So we graphed things like this yesterday. This is a little bit out of order, but so I don't know what that looks like. Let's do a table of values. What's a little bit weird with this table of values from any other table of values that I think we've done? Do you know what's going to be weird or backwards about it? What do we usually pick to plug in? The x's or the y's? The x's. But if I pick x's to plug in here, it might not work. So instead of picking x's, let's pick y's. It feels really weird, but that's the only way this is going to work. So let's pick our y's. Let's pick our exponents to be -1, 0, and 1. So now it's really similar to what we did yesterday. 4 to the -1, that's 1/4. 4 to the 0 is 1. 4 to the first is 4. So like the math of the exponents is the same as we did yesterday. We just ended up with them in the opposite spots. Right, let's graph these. 1/4 -1, 1 0, and 4 1. Yesterday we also did the -2 and +2. Like if you did +2, you get 16. So like 16/2 is on the graph way out here. And 1/16 common -2 is on the graph. So there's what our log graph looks like. So it's kind of the same points as the exponent graph. It's just the x and the y have traded places. After that, just like we did yesterday, we'll think parent functions. So what is that plus 3? Oh, this is one of those tricky ones. Do you know what that plus 3 does on number 2? Is it an up 3 or is it a left 3? It's one of the two. What would make it, it's up. What would make it be left? What would have to happen to make it be a left 3 instead of an up 3? Do you know? It'd have to be in parentheses. Right now this is only taking the log of 4 and then adding 3. So this is an up 3. Because it's not in parentheses. As opposed to number 3. Look at number 3. There's the difference. Number 3 would be a left 3 problem. So up 3. This becomes very similar to what we did yesterday. We don't really plug things in anymore. We look at our original table, and let's see, up 3 would be adjusting the y values by up 3. So our y values are now 2, 3, and 4. We didn't do anything to the x values. 1/4, 1, and 4. So let's plot those points. 1/4, comma 2, 1, comma 3, 4, 4. Curve. And kind of like yesterday, it's probably a good idea to check. We said it was up 3, so compare this graph with our original graph. Maybe it's hard to tell exactly, but it's definitely been moved up 3. Also the thing yesterday where a few people don't like rewriting the table, they just want to grab those points and shift each point up 3. That's fine. If you can go point by point and move each point up 3 spots, that's okay. If you're going to forego the table, please at least write up 3 so I know what you're trying to do in case you mess something up. Number 3. The plus 3 is in parentheses, so that's a left 3 thing. So that means we'll adjust our x values. And again, we're not really, all we're doing is borrowing from the first table. We're starting with that first table and changing things. So left 3 is going to be minus 3 from the x coordinates. So 1/4 minus 3, 1 minus 3, 4 minus 3. We didn't do anything to the y's, so those are still the same. So 1/4 minus 3. If you don't want to figure out what that is, you can kind of do the math on the graph. So go to 1/4 and then back up 3 spots. 1, 2, 3. Put you at negative 2.75. Whoops, that's supposed to go down 1. Yep, thank you. That's a great example of why I don't like doing it by points. I like doing the table. If I mess up trying to do too many things at one time. Maybe I need some new whiteout as well. This is gross up here. Yeah. There we go. Ooh, plus the fumes. So there we go. Negative 2.75, negative 1. Then negative 2, 0, which is right where my whiteout is now. Right there. And then 1, 1. It may be hard to see that this turns into an asymptote over here, but if we have that original graph to look at, we know all we did was shift it to the left 3. So the idea is this is really similar to what we did yesterday. Switch the x and y's at the beginning, but then after that it's kind of the same thing. Do you know your parent functions? Do you know not do you know your parent functions? Do you know the transformations? How about a negative x on number 4? What does that do? What's that? Flip it. Now, does it flip it left and right, or does it flip it up and down? And how do you know it flips it left and right? Because it's on the x. If it's messing with the x, it's going to mess with the left and right stuff. So that means we need to flip our x values. Again, I'm not coming up with anything on my own here. I'm just borrowing from that first table we did. And I'm just going to change all the x values to negatives. And leave my y values alone. And then plot what I've got. -1/4, -1, -1, 0, and -4, 1. So 3 points, but I also know what the original looks like, and maybe I can visualize a flip that's happened. And then double check. I said it would flip left and right, so I compare that graph to the original graph, and I would say, yep, that flipped left and right. Number 5, natural log of x. Well, what's the base of a natural log? Yes, but be more specific. Natural log is the same thing as log base e. So I'm going to rewrite it as log base e of x. No math teacher would ever write that, because log base e is natural log. But the reason I write it that way is because now it's easy to see what the base is, and I can do e to the y equals x. And so now instead of dealing with a log problem, I'm dealing with an exponent problem. -1, 0, 1. But I always pick the exponent, and since the exponent is the y value, that means I'm picking y's again. Let's see, e to the -1. Do you remember what that was from yesterday without going through the whole steps? What did we land with for what e to the -1 is approximately? About 1/3. Because e is 2.7, -1 flips it over. But for graphing purposes, 2.7 is close enough to 3, especially when we're doing 1 over that. Right? E to the 0, that's 1. And e to the first is 2.7. So 1/3 -1, 1, 0, 2.7, comma 1. Not much of a graph there, but we've seen what the shape looks like. So we can sketch in the natural log graph. And again, there's sort of our parent function points for the natural log graph. But even then, you don't memorize them. You just figure out what they are by starting with -1, 0, 1. And then use the parent function things. let's skip 6 because we already did. Well, let's not skip it yet. Tell me what the negative inside does. Which way does it flip it? A left and right flip. So we would change our x values. We already did one like that. So let's jump ahead to number 7. What's that negative sign do? It's another flip. But which way is that flip? Up and down. I would say across the x-axis. That sometimes confuses people. Because which variable are we going to change to accomplish an up and down flip? The y. So it does flip across the x-axis, but some people when they hear x-axis they think you're changing the x's, you're changing the y's. So to avoid that, I'm just going to say it flips it up and down. And we'll change our y signs. Again, I'm not really plugging anything in. I'm just taking that first table and making the necessary changes. Changing the signs of y. And I already have the values, so I don't have to think through again, oh, what is e to the negative 1? It's 1/3. We've already done that. 1/3, comma 1, 1, comma 0. 2.7 negative 1. So this looks like it's going to be upside down, but that's exactly the point. We said it was going to flip up and down. So we compare our two graphs. My artistic work isn't perfect, but that's an up and down flip. And then lastly, one more time, what's that +3 do at the end on this one? Is that a left 3 or an up 3? Yes, it is an up 3. So that means we'll tweak our y values by 3. So -1 + 3. 0 + 3, 1 + 3. Our x values are the same. (1/3, comma 2, 1, comma 3, 2.7, comma 4. There's our picture. And if you take a minute to compare, it's up 3 from the original. Number 9, questions, but questions about the picture. So if we look at the picture, what is the domain of f for natural log? So what's the domain of natural log? Can't zoom out to get it all in there. 0 to infinity. Yes. What about the 0? Parentheses or bracket? Parentheses, because we never get there. What's the range? What y values are covered? All of them. So -infinity to infinity. What is the asymptote? Oh, we didn't talk about the asymptote, but I mean, not explicitly. We sort of. What's the asymptote for that graph? 0. Don't just say 0 though, because 0 is just a number. What about 0? About x = 0. X-intercepts, so it crosses the x-axis at 1, 0. Y-intercepts, none. And 2 points again, that's just looking back at our table. 1, 0, and E1. It only wanted 2, so we didn't have to do the 1 over E thing.
And you said if we were to hit 2.7, comma 1, that would work too?
Yep.
Okay.
That'd be fine. Well, we can talk about that later. All right, what's on the test is, oh shoot, I forgot the exact numbers, but 10 basically worksheet 1 problems, 5 worksheet 2 problems, mostly dealing with e to the x, not 5 to the x or 2 to the x. We want you to be comfortable with e. And then 6 worksheet 3 problems, mostly dealing with natural log, not log base 2. So make sure you're okay with e is 2.7, 1 over 2.7 is 1/3. You're comfortable with all the e stuff. There is a bonus, and it's from the last unit, which is the circles, ellipses, hyperbolas unit. So there's a little bit of hint there. Okay, again, so tomorrow we'll come in, I'll answer questions from worksheet 3, hopefully get everything cleaned up and cleared up. Then we'll take the test, and then we'll do notes for the next day, but the next day notes are pretty easy.